So hello everyone, this is the summary video of chapter real number. This is the first chapter of class 10th. So in this chapter, we learned about four things. So let's start with the first one. The first one was Euclid's division algorithm. This is Euclid's divisions algorithm. Okay, let me take the pen. Euclid's divisions algorithm. Using this algorithm, we found how to calculate HCF of some numbers like this. Okay, this theorem is basically deals with the divisibility of a number. It actually says that if a number A is divided by B, there will exist Q and R unique for these two numbers. So it can be written as A is equal to BQ plus R. So this was the first thing. Now coming on to the second part. These are examples. So the second part is fundamental theorem of algorithm. So fundamental theorem of algorithm basically deals with the multiplication of integers. By using this, we can see how any integer is can be written as the product of prime numbers, and with the help of this, we saw how to draw a factor tree, and by using these theorems we calculated the LCM and HCF of some numbers. Okay, so moving on, this is where we calculated. So this was our third part. By using this theorem, this is actually based on the fundamental theorem of arithmetic, but by using this theorem, we proved the irrationality of some numbers. This theorem basically says that if P divides A square, that means A square is divisible by P. This means that A is also divisible by P. Okay, so here we saw how it is possible. So this is the proof. We learned a method of proof. That method is called as a proof by contradiction, in which what we do, like if we have to prove anything as an irrational number, at first we assume something contrary, that like root 2 is a rational number, and then we go on to the next step, and finally we conclude that this contradicts that our assumption contradict a fact, and that's why our assumption is correct. So we basically conclude that assumption is incorrect, hence the number which we have taken is rational number. So this was the third part. Coming on to the fourth one. Okay, here's another example. The fourth one is the decimal expansion of rational numbers. In this part, we saw how a rational number whose decimal is a terminating can be represented in the form of P by Q, where Q will be equal. Q will have the prime factorization of the form 2 raised to m into 5 raised to n. Okay, so these are examples. Okay, here's the theorem. Now consider some more example. We concluded one more theorem, that if rational number P by Q, if there is a rational number P by Q, where Q has a prime factorization of 2 raised to n, into 5 raised to m. This means that its decimal expansion will be terminating. Okay, then we again came to another theorem. This theorem implies that if if the prime factorization of q is not equal to 2 raised to n into 5 raised to m, 2 raised to n into 5 raised to m, this means that its decimal expansion will not terminate. So what its decimal expansion will be? It will be, let me write it here. It will be non-terminating, repeating. So this is our last theorem, and that was all the summary of the chapter. So you guys now do some practice and give the test and exercises which we have created for you guys. So thank you all. This was the first chapter of class 10. We'll meet you in the next chapter. Till then, bye-bye, everyone.